Okay, ladies and gentlemen, we're going to review here, or go over, I should say, chain rule, but you're going to see it's going to be chain rule with product rule, power rule, and quotient rule. So these are things that we went over in class. So I just want to go over some of these questions. We're going to go over the odd numbered questions here, and we're going to take the derivative now. So if we're going to find the derivative, because they're asking us to differentiate the following functions, we're really looking for dy dx, also known as y prime here. So y prime, or dy dx, differentiate with respect to x the y function, which is given. And you guys can see here we have to use the product rule. And we use the product rule because essentially you have the product of two functions here. And let me go back here. There we go, 2x. Okay. X times sine 2x, product rule now. So let's see what happens. Remember the product rule, you're going to pull out the first function, differentiate the second function, plus the second function. Okay, and you're going to differentiate now the first function. So, I may not color coordinate everything here for you guys, but I want you guys to at least see what we're doing when we start the product rule. Now, the first derivative here is going to be chain rule. So you have to remember chain rule. I guess that's the title of this, chain rule part 2, because you need to know the derivative of sine, which is cosine, and then you need the chain, which is where people will make their mistakes. So you want to remember you got to differentiate 2x as well, which will be 2. So, ladies and gentlemen, this is the complete details here. Now, the next derivative is just 1. So be careful, because it's very difficult to see sometimes what is left and what is, what is there and what is not there, I should say. You have x, you got cosine 2x, you got a 2. And then that's going to be plus, if I go back now, sine 2x times the number 1. So this is the details here. All right, so that first derivative is going to be 2x cosine 2x plus sine of 2x. So there you go, ladies and gentlemen. This is going to be what we call chain rule part 2, because right over here, you'll have chain rule, and it's mixed with product rule. So there you go. I'm going to go over the odd numbered questions here. So this is 2. We're going to try number 3 now. Okay. Now, y prime is the derivative of 1 minus x plus 2x squared, and this will be raised to the 5th power here. Okay, now if you look at this, you're going to say right off the bat, oh, I've given it to you guys this way. The book might say, hey, you got u to the 5th power. The derivative of any base to the 5th power would be 5u to the 4th power. But by chain rule, you got to differentiate the u. I've given you the Jaime Escalante notation. Okay. So I'm going to write it down here as well. There's like a picture of the derivative of chain rule, but this is chain rule. So, ladies and gentlemen, yes, pick your poison. Here's the deal. Now, if you said, well, what's my u? This is the u, or this is the triangle. So when we differentiate this, y prime will be 5, 1 minus x plus 2x squared to the fourth power times the derivative of that function. So I'm going to need more space here. And you say, what's the function? 1 minus x plus 2x squared is the function, or your u or your triangle, whatever you want to call it. So at this point here, remember, this is the chain here in chain rule. So when you take the derivative now here, it'll be negative 1 plus 4x. So don't forget the derivative here of that chain. Now, y prime is 5, 1 minus x plus 2x squared to the fourth power. Now, we can write it as 4x minus 1. I prefer to do that. You can write it as negative 1 plus 4x, I guess. But, ladies and gentlemen, we like to actually start our terms with positive numbers. So, here you guys go. So, this is going to be, again, chain rule mixed with product rule. Okay. There's an even question. We're going to go to the next question. This is odd now. Okay, we're going to do the odds. What I'm going to start off is reminding you guys, if we're going to do any sort of differentiation and we have a square root, use the rational exponents. Describe your function that way with rational exponents. The radical is a base to the 1/2 power. Now, you look at this and you say, I need the derivative. Well, you're going to differentiate again y with respect to x, where y is x. 1 plus 4x to the 1/2 power now. So if you, again, recognize that you have a product of two functions, this will, again, be product rule here. And I'm going to abbreviate it like I did before, just PR for product rule. All right. Let's get the derivative now. Pull out the first function, differentiate the second function. Plus the second function, and differentiate the first function. Now, here, we're going to use, again, power rule with chain rule. And maybe I should say we're going to put that derivative, since we need some space maybe, down here. So this derivative will be 1/2, 1 plus 4x to the 1/2 minus 1. I'll put it here, but it's negative 1/2. Now, don't forget the chain. This is where students will forget. So again, this is like your u, and you have u to the 1/2. Okay, so the power rule with chain rule, essentially down here, the derivative will be, well, if I remind you guys, remember this formula here, right? Anytime you differentiate a base to the 1/2 power, it's 1/2 to the square root of u. So I gave you guys that. And also, don't forget the chain rule version, I should say. And that's essentially what we're doing here. So if you said, okay, can I just do that from the beginning? And remember, we're having a little issue with this eraser. Yeah, let's do it this way. So if you said, I really liked that, I followed your advice, good. Went over to square root 1 plus 4x. And now the derivative of the chain is just 4. Don't forget over here, your derivative of x is 1. So ladies and gentlemen, let's put this all together. But remember, sometimes it's hard to see what is left here. So this is why I go back and highlight what's left. All right, so I'm going to put this all together, and let's not simplify everything. Like, for example, I'm going to write it this way. This is 4 times x over 2 square root 1 plus that 4x plus the square root 1 plus 4x. Divide here. 2 goes into 4 twice, and your derivative becomes 2x over square root 1 plus 4x plus the square root of 1 plus 4x. So, ladies and gentlemen, here you go. And there it is. All right, that's number 5. Now, 6 is even. We're going to go to 7. And in number 7, let's take a look. We're going to differentiate this. So, y prime is the derivative with respect to x of the y function, which is x over square root 6x plus 1. Now, notice this. You have a quotient, so you got to use quotient rule now. So remember, quotient rule, you're going to take the denominator and you're going to square it. Bring the denominator function up, take the derivative of the numerator. But don't forget, this is going to be subtraction of the numerator times the derivative of the square root of 6x plus 1 now. Okay. So double check here that this is our quotient rule. The derivative of x is just 1. Now, this derivative, again, if you want to dive into those details like we did the last time, what you really have is the derivative of 6x plus 1 to the 1/2 power there. All right. Go back and remember what we did here, right? There's a formula for taking that derivative here, and it's a really handy formula for you guys to know. This is why I'm bringing it down and why I'm emphasizing it, right? Because you have, this is u to the 1/2. So this derivative, and I'll do it down here, is going to be, again, 1 over 2 square root 6x plus 1 times the derivative with respect to x of 6x plus 1. That's going to be 6. So this derivative, don't forget 2 and 6, or 6 divided by 2 gives you a 3. That'll be over the square root of 6x plus 1. There you go. So, ladies and gentlemen, y prime is equal to, let's go back and see what is really here. The square root of 6x plus 1 times 1, which will be itself, minus an x times the derivative we just got divided by this denominator. Okay, let's do some algebra and some arithmetic. Let's find out what this is. Square root 6x plus 1 minus 3x over square root 6x plus 1 divided by the square root of something squared. That gets rid of the radical, so you just have 6x plus 1 down here, okay? Now, you guys may recognize some of this because we did talk about that algebra here, right? You say, okay, what do I do now? Well, let's make this a little bit more notation correct, because in the process, there we go, notation correct. And not only that, I'm going to remind you guys that in the numerator, we got a whole number minus a fraction. So what I'm going to remind you guys is take that same denominator, square root of 6x plus 1. Let me try to write it pretty clearly. Multiply that by the top and the bottom here, okay, that radical. And again, doing a little bit of algebra, you're going to end up with, again, just 6x plus 1 in the numerator over the square root of 6x plus 1 minus the 3x over your square root of 6x plus 1 simply divided by 6x plus 1. And that's a complex fraction. So just perform your arithmetic with your fractions now. This will be 6x plus 1 minus 3x over the radical of 6x plus 1. And I'm going to put divided by 6x plus 1 because that's really what's happening, okay? And now we say, that'll be 3x plus 1 over the square root of 6x plus 1 times 1 over 6x plus 1. And so, ladies and gentlemen, here we go. It's 3x plus 1 over, you can say 6x plus 1 to now the 3/2 power here. Or you can write it as you see it. So you say, what do I mean? 6x plus 1 times the square root of 6x plus 1. Make sure the 6x plus 1 is in a parentheses, though. The first 6x plus 1. So, ladies and gentlemen, there you go. Chain rule part 2. And this involved quotient rule. All right. Okay, let's look at question number 9 here. Okay, we're going to get that derivative as well, using chain rule and so on. So I would say first start off, write your y as x minus 2 over x plus 2 to the 1/2 power. Write it with a rational exponent because that's what that is, okay? The square root of u, remember, is u to the 1/2. This is what we're saying now. So now when you take your derivative, y prime dy dx is d dx x minus 2 over x plus 2 to the 1/2. That's 1/2. Now go back again and think again here. Okay, let's go back and think about what we have, right? This again is u to the 1/2. So if I have to differentiate u to the 1/2, we're talking again power rule with chain rule. So remember what I gave you guys, that nice formula times du dx, where this is my u again, and you guys can see that there. That's the formula I gave you. Now combined with chain rule, the chain, there you go. So y prime will be the following: 1 over 2 square root of x minus 2 over x plus 2. Don't forget, we have to differentiate what u is, and that's x minus 2 over x plus 2. This is the u part that we have to differentiate. And this is where we're going to use quotient rule. So we're going to go over all the details here. So let's differentiate this. All right. So that derivative by quotient rule, we take the denominator and square it. Bring up the denominator, differentiate your numerator. Bring out the numerator, differentiate the denominator. Quotient rule. The nice thing about this question is you got these nice ones here. So we end up with just, if we write down the x plus 2 times 1 minus the x minus 2 times 1 over x plus 2 squared. Let's get some more paper. All right. Now distribute. Combine like terms. X plus 2 minus x plus 2 over x plus 2 squared. So this will be 4 over, now again, it's a weird crease. The x's cancel. 4 over your x plus 2 squared. Now that derivative here was just the chain. You say that's 4 over x plus 2 squared. So this is what I'm saying. This is 4 over x plus 2 squared. So let's go back and take a look and see what's left. Well, we have this portion here. Let's highlight that, right? This portion times what you see here. So y prime equals 1 over 2 square root of x minus 2 over x plus 2 times the 4 over x plus 2 squared. Okay, we're going to do some simplification here so you guys are aware. So take a look, because we got to simplify that. 2 over, I'm going to give you guys the simplification in steps. Okay. So I want you guys to also remember a little bit of beginning algebra or intermediate algebra. It doesn't really matter. If I have a quotient to a power, if you guys remember, you should say quotient. Well, let's go back here and move this. Properties here. Properties of exponents. This is 2 over now. X minus 2 to the 1/2 over x plus 2 to the 1/2 x plus 2 squared. And another property I want to remind you guys of, if you have a to the n over a to the m, okay, you subtract your powers here. Doing a little bit of your algebra here. So y prime becomes 2 over x minus 2 to the 1/2. And I guess we should say, what property do we use here, right? Let's look at the powers here. 2, 1/2. We got to subtract the powers here. So 2 minus 1/2 is 4 halves minus 1/2. That is 3 halves. So we write down x plus 2 now to the 3 halves power there. And remember this other video I gave you guys, and I said you can actually, we could leave it like this. And in some ways, you're fine. Okay? There you go. You actually have the derivative. But, in the future, you might see the answer this way. Remember what I did? I did a video for you guys that was how to simplify, I should say, rationals. 3 halves is a improper fraction, which is really 1 and 1/2. So if you refer back to that video on how to simplify this, which is why I wrote it, because sometimes students looked in back of the book and they would see the square root of x minus 2, and then they'd see like an x plus 2, then a square root of x plus 2. And they would not know how the book got that answer. So, in the future, we might see something like this, which is why I'm talking about it. But your first answer, would be okay for now. But the second answer, maybe in the future, you might want to think about, which is why I wrote that video. So here's the chain rule part 2 and how this works with, various settings like product rule and power rule and quotient rule. There's number 10. Number 11. Okay. All right. Let's see. How many do we have? 12. Oh, this is the last one. Good. We have a nice trig function. So we did go over, trig functions, but let's talk about this one here. Okay. I'm going to write y again. A lot of times students don't know what secant squared really is algebraically. So all that is secant to the second power. And that's plus, this is kind of not a question. It's not a very, well, okay, whatever. I'm going to leave my comments alone. All right, number 11. So you got, again, power rule with chain rule. So if you have u to the second power, that's really 2u times du dx, right? Power rule with the chain rule. So when we differentiate y, we're differentiating secant 2x squared. We got to put a curly bracket plus the derivative of secant of 4x squared curly bracket. Derivative of a sum is sum of derivatives. And maybe we just write it this way first, and you guys can see, oh, I'm differentiating, a sum here, I guess. So maybe some people need to see that first. If I could get this to cooperate, it's hard. So maybe now we'll say derivative of sum is sum of derivatives. So d dx secant 2x to the second power, we need that derivative plus the next derivative. Okay, maybe that's helpful. And now, specifically, we're going to use the chain rule. So in each case here, this is u. Okay, and this is u. So let's bring out some more space here. And I'm going to do the derivative here, okay? So the derivative of secant is secant tangent, but don't forget the chain here. So this is chain rule. So if you wanted, we can remind you guys what just happened. If I have secant u, the derivative of secant is secant tangent u times the chain, which is du dx. And we have to differentiate now the 2x, which is your 2. So this is the first derivative there of secant of 2x raised to the second power. You repeat the process with secant of 4x raised to the second power. So this becomes, down in here, secant 4x tangent 4x, derivative of 4x, and this is going to be the number 4 here. So take a look here. There's all the gory details. Y prime becomes 2 now. Secant 2x tangent 2x plus 4 secant 4x tangent 4x. Ladies and gentlemen, there you go. And then that concludes our short video on looking at chain rule in a little bit more depth and with these particular questions. So there you guys go. Take care. Stay safe. Have a wonderful weekend.